Advanced Algebra 2, Concept 8, Modeling with Quadratic Functions. This is part 2 of the notes. This is where we're going to learn how to write quadratic equations using technology. So you'll want to get a TI 83 or 84 calculator for work with these notes. Real-life data that show a quadratic relationship usually do not have constant second differences because the data are not exactly quadratic. They're close. Relationships that are approximately quadratic have second differences that are relatively close. So if you found second differences in this table comparing miles per hour to miles per gallon on the output, you'll find just that the second differences in the y values will hover around that. So many technology tools have a quadratic regression feature that you can use to find a quadratic function that best models or fits the data. So these set of notes, I'm going to show you how to do that on a Texas Instruments, a TI 83 or 84 calculator. You can also do this on Desmos, and I will show you that in class. So example 4, using a quadratic regression. The table shows fuel efficiencies of a vehicle at different speeds. Write a function that models the data. Use the model to approximate the optimal driving speed. And so for most vehicles, there's an optimum speed that you would drive at where you would get the most miles per gallon. So the first thing that you want to do is that we're going to be on a TI 83 or 84 calculator. So I'm going to write down what the step is and then go to my calculator and actually show you how to do that. So you're going to go to the Stat button on your calculator, and then in that menu you'll go to Edit, and you'll enter your X values into L1 or list number 1, and then you'll enter your Y values into list number 2. So move to your calculator. Now you're going to press your Stat button, which is kind of the upper middle, and you can see how mine is lit up. And then you want to go into the Edit menu, so you'll press Enter. Now you're going to enter values into your list 1, your X values, and then your Y values into your list 2. I have already entered mine there. If you have something in the list, you can go up to the list name and then highlight that and press clear and enter, and it will clear everything out so you can have a fresh spot. All right. So take a moment, pause the video, take a moment, and get the values entered into your calculator. All right, now let's talk about the next thing that you want to do. You're going to go back to your Stat button, your Stat menu, and then you're going to arrow over to the Calc key, Calculate. And then you're going to arrow down to number 5 that says Quad Reg, which means quadratic regression, and press Enter. And what we're looking for is a quadratic equation that fits the data. We also want to see what's called our correlation coefficient, our R value. If you do not see an R value, then you can turn on that program by going to second and then 0, and you'll see something called your catalog come up. You're going to arrow down until you see the words diagnostic on, and you'll hit enter twice until you see done on your screen, and then that will turn on the program to run a regression. So let's go back to the calculator and do those steps. All right, we are back at the calculator. So now I'm going to press Stat, and now I'm going to arrow over to Calculate. Notice number 5 is Quad Reg, or a quadratic regression. So I'm going to arrow down, or I could just press number 5 and then Enter. Now I'm just going to press Enter through this list because this is just saying X is list 1, Y is list 2, and we'll just press Enter. All right, there we've got our equation. So we're going to come back and capture this, but what I'm looking here in the bottom of my screen is for a correlation coefficient, and I do not see it. So I'm going to do the steps to turn on that program. So I'm going to press second and 0, and that will get me into my catalog. And then I'm going to arrow down into the D's. But if I press alpha D and alpha D twice, that's going to put me into the programs that begin with the letter D. What I'm looking for is diagnostic on. I'm going to press enter and then enter again until I see done. Now I'm going to repeat those steps to run a regression. So I press my stat button, I arrow over to calculate. I'm going to press number 5 this time, and then I'm going to arrow through this screen. All right, now here's what you want to capture in your notes, and you're going to put it in standard form like this. So you'll say y equals negative 0.014097, let's say, x squared plus 1.36622x plus negative 7.14405. Now capture the r, and in this case it's r squared. The correlation coefficient is going to be squared. I'm going to capture 3 or 4 digits, 0.9992, and that shows that I have a very strong close fit. So this equation really closely matches that data. Let's go back to our note sheet. All right, let's capture that equation. So I usually go to quite a few decimal places, negative 0.01409, so we went to 5 there. I went to 5 here in each of those 5 decimal places. The more decimal places that we go to, the more accurate this curve will be to fit the data. All right, so I make a note of my correlation coefficient r squared, and I see that it's a good fit. Now, I know that you can't see my answer, so let's talk through the answer to the question. It says, use the model to approximate the optimal driving speed. So that's going to be the driving speed that gives us the most miles per gallon. You'll probably guess that it's between 45 and 50 miles per hour. Let's go back to the calculator and take a look at the curve and see if that can help us find that value. I'm going to take a look at the graph of this. And so what I'm going to do is say zoom and then 9. That's going to, whoa, sorry about that. So the zoom and then number 9, and that's going to optimize my window. Sorry, let's see. I need to look at my stat plot. So I'm going to go to second. All right, sorry, I just had to do a little adjusting. So now I have the data points graphed on my calculator along with the curve. And I will be giving you a sheet of notes that will explain those extra steps on how to do that after you run the regression to actually see the graph of your data points and then the graph of the equation on the curve. So there is something called trace. So you can trace. And right now, my calculator is going to trace my data points, but I'm going to toggle down and it's going to trace my equation. So keep your eyes on the y value, and we're going to try to look and see where the y value is the greatest. It is still increasing as we get close. 48, I'm looking at my x value, 40 round, if we round, it's 49. And then I start to decrease. So we can see if we approximate, it's right around 49 miles per hour that our miles per gallon will be maximized. So this is how you can use technology and the graph of the data points and then that quadratic regression equation to help you answer a question like, what's the maximum? We could also find the vertex algebraically as well. All right, so I know you cannot see my answer to the last part of the question, but the answer to the optimal driving speed would be about 49 miles per hour. All right, now this table shows the estimated profits Y in dollars for a concert when the charge is X dollars per ticket. Write and evaluate a function to determine what the charge per ticket should be to maximize the profit. So what we're going to do is follow the same steps and enter the X and Y values into our list 1 and list 2, and then run a quadratic regression. So go back to your calculator, go to the stat menu, and enter those values. I will do the same. and pause the video, and I'll do the same. You can come back and look at the answer on my calculator. All right, we're back to the calculator work. So you're going to press Stat and then enter at your Edit menu, and then enter your X values in List 1 and your Y values in List 2. And then we're going to run regression. I'm going to do some extra key steps so that I can see this equation graphed on my calculator. So here's our quadratic equation. Capture that in your notes. Y equals negative 100x squared plus 2000x minus 1000. Notice this is a perfect fit. We have a correlation coefficient of 1. Let's look at the graph of this now. And so our question is what price for X will maximize our income? So I'm going to trace, but I want to trace on my equation. And so I'm just going to look and see. So it's going to be, I'm looking at the money that's coming in. It's still increasing. Oh, now it's starting to decrease. So it looks like a ticket price of right around $10 will maximize that. So capture that in your notes as well. All right, so you should have this quadratic equation down for this data. The correlation coefficient, r squared equals 1. It's a perfect fit. And then the point 10, about 9,000. So $10 in ticket price will make a maximum $9,000 in profit. So here's a new table of data to try your hand at running a quadratic regression again. So it shows the results of an experiment testing the maximum weights in tons supported by ice thickness. We're going to write a function that models the data using our calculator, and then figure out how much weight can be supported by ice that is 22 inches thick. So go to your calculator and enter that data. All right, here we are back at our calculators. So we're going to go to Stat, into our Edit menu, and enter in that data for List 1 and List 2, X and Y, and then run a regression, quadratic regression. I'm just going to do a couple extra keystrokes so that we can see the curve graphed right on top of our data points. So here's our equation. Let's go to like 4 or 5 decimal places. So capture that equation. Ooh, look at our correlation coefficient. It's a very strong fit. And now let's take a look at this graph. Now notice our question was different. It said what are the tons that could be supported by 22 inches thickness of ice. So I'm going to use my trace menu. I'm going to toggle so I'm tracing on my equation, and then I'm simply going to type in 22, and then it's going to put 22 into my equation for me. And so it is about 32.4 tons of ice that will be supported by 22 inches thick of ice. All right, make sure that you have captured that equation in your notes. And the correlation coefficient, 0.999, I think it was even one more 9. It's a very good fit. And so an ice thickness of 22 inches can support a weight of about 32.36 or 4 tons. And notice that this falls right into the reasonableness of our table there. All right, that concludes the notes for writing quadratic equations, using technology. A quadratic regression.